students, so welcome to the lecture number 7 of chapter 7. In the previous lecture we have solved two questions from exercise 7.1 based on two congruency, that is SAS congruency and ASA congruency. And today in this lecture we are going to solve another two questions from the same exercise. Okay, so let us do the first question, that is question number 3. So first let us understand this statement. What is given in this question? It is given that there is a figure, and in this figure AD and BC are equal perpendiculars to AB. Okay, we have to understand each statement, each term. There are two terms, equal and another term is perpendiculars. Okay, so it is given that AD is perpendicular to AB. AD means this. So AD is perpendicular to AB. This is the line AB. Okay. Now to this line, another line AD is perpendicular. Perpendicular means 90 degree. It makes 90 degree at the point A. Okay. So AD is perpendicular on AB. Clear? Similarly, BC is also perpendicular to AB. There is another line BC which stands on AB. This is AB. This is BC. Right? Now this BC is perpendicular on AB. Understood? So suppose this is BC. Now it is given that BC is also perpendicular on AB. Are you clear? Okay. Then another term arises, equal. Equal means the distance from A to D is equal to the distance from B to C. Okay. So here also this distance is equal to this distance. It is given in this question. Okay. Perpendicular means the symbol of the perpendicular is like this. Reciprocal of T, letter T. Okay. So now from this data, what we have to solve? What we have to prove? We have to prove that CD bisect AB. Okay. What is the meaning of bisect? I have told you what is a bisector, line bisector. A line bisector is a line. Line bisector is a line. It is a line which divides another line into two equal halves. Suppose we take CD as a line bisector. Now this line divides another line AB into two equal halves. Understood? So here also, if we take AB as a line, then this is the bisector. Means this line divides AB into two equal halves. Suppose it is the line CD and the meeting point is O. So it means what? That it is the line bisector. It means it divides AB into two equal halves. It means OB distance is equal to OA. Are you getting my point? So here also you have to prove that this distance OB is equal to this distance, because this is the line bisector. It bisects this line AB into two equal halves. OB is equal to OA. Okay? So this is the proof, or this need to be proved. Right? So let us first write what is given from this statement. Right? So given. So first it is given that AD is perpendicular on AB. So symbolically you can write AD is perpendicular on AB. Okay? And BC is also perpendicular on AB. So you can write BC is perpendicular on AB. Next, this distance is equal to this distance. So you can write AD is equal to BC. Okay. Now, what is needed to prove? We have to prove that CD bisects AB. It means what? It means this distance is equal to this distance. So we have to ultimately prove that OA is equal to OB. We have to prove this statement. Okay, you have to understand this. Right? So let us prove how we can find that this distance and this distance are equal. right? So in order to find it, we have to compare two triangles, OBC triangle and OAD triangle, right? If we compare these two triangles and if we can prove that these two triangles are congruent, then we can write that this distance or this side is equal to this side of another triangle. Okay, so our first and ultimate goal is to prove that these two triangles are congruent by using either SAS congruency or ASA congruency. Right? ASA means two angles and included side, not AAS. No. I am talking about ASA, two angle included side. Similarly, SAS means two sides and included angle. Okay, do not write like this, SSA, no. Okay, so let us compare these two triangles. So, between triangle OAD and triangle OBC. So, while writing, always name them in a proper order. OAD and OBC, not OCB. Okay, so let us compare them. So first thing is, as you can see, in this triangle, this angle is equal to this angle because it is also 90 degree. It is also 90 degree. Yes or no? Yes. So we can write that this angle A or OAD is equal to this angle OBC is equal to 90 degree. Okay, why? Because it is given. Clear? Next thing, this side of this triangle BC is equal to this triangle's this side. AD is equal to BC. It is already given in the statement. So we can write in the second statement that AD is equal to BC. Okay, why? It is given. Now, from the three statement, two statement has been found out. Now our target is to find the third statement. Okay, see, this stands for angle. Yes or no? Yes. This stands for side. Right? So it goes for AS, then A. So we have to find the next angle. Which two angles of this corresponding triangles are equal? We have to find it. Okay, so let us find C. Whenever the line AB and the line CD intersect each other, then two opposite angles created. Right? Now these two opposite angles are equal. Why they are equal? Because they are vertically opposite angles, and you know two pair of vertical opposite angles are equal. So can we write that this angle is equal to this angle? Yes, these two angles are equal. Okay, so what we find? We find that this angle is equal to this angle. That means AOD is equal to BOC. Okay, so let us write it first. AOD is equal to BOC. Okay, we have found out it. Right, so it stands for an angle. So do I get ASA congruency here? Let us check. So what we find from the three statement, we have found that in this triangle, this angle, this side. Again I am telling you, in this triangles, this angle and this sides are equal to, in this triangles, this angle, this side. Now tell me, is it ASA congruency? Tell me. Here we have two consecutive angles, right? Then tell me, what is the included side for this triangle? For this triangle and for this two angle. If it is a triangle and these are the two consecutive angles, then OB must be the included side. But here it is given that BC. Here we have found BC. So BC is not the included side. Okay, so it is not ASA congruency. Are you getting my point? It is not a ASA congruency. because it doesn't follow ASA. No, it follows AAS. So the third assumption is not valid here. Right? The third assumption is not valid here. We have to find the third assumptions. How can we find it? It is very easy also. See. What we have find? We have find that in this triangle, this angle is equal to this angle. First condition. In this triangle, this angle is equal to this angle. Second condition. So in two triangles, two angles are equal. Then can we write that this angle must be equal to this angle? Can we write it? Let us take an example. Okay. Suppose there are two groups, group 1 and group 2. In group 1, there are 3 students, Abhay, Balram and Jitendra. Okay, in group 1 there are 3 students, Abhay, Balram, Jitendra, and group B there are 3 students, Jyoti, Gautami and Kishori. Okay, now it is given that in group 1 they have totally 200 rupees. It is given. And in group B they have also as a whole 200 rupees. Clear? Next, it is given Abhay has 50 rupees. Balram has 130 rupees. Okay, and Abhay has 50 rupees, Balram has 130 rupees. Now the condition is the amount that Abhay has is equal to the amount that Jyoti has. It means the amount with Abhay is equal to amount with Jyoti. Okay, so can we write that Jyoti has also 50 rupees because amount of money with Abhay is equal to amount of money with Jyoti. Clear? And it is also given that the amount of money with Balram is equal to the amount of money with Gautami. So, since Balram has 130 rupees, then Gautami has also same. Like this. See, in this triangle, this angle is equal to this angle, this angle is equal to this angle. Similarly, in this two group, the money with Abhay and the money with Balram is equal to the money with Jyoti and the money with Gautami. Now, can we say that the amount of the money that Jitendra has is equal to the amount of money that Kishori has? Can you tell this? Let us find out whether it is correct or not. Okay, since Abhay has 50 rupees, Balram has 130 rupees. Right? Then if we add them, we will get 180 rupees as a whole. Okay, then as they have 200 rupees total, then out of the 200 rupees, 180 rupees is with Abhay and Balram. Then the rest amount that Jitendra has is equal to how much? 200 minus 180, that is 20 rupees. So Jitendra has 20 rupees. Now let us find for Kishori. Right? Here also, the sum of the amount that Jyoti and Gautami has 180. Right? Now, Kishori has how much amount of money with her? 200 minus 180 is equal to 20. So here also we get that Jitendra has 20 rupees. Here also we get that Kishori has also 20 rupees. So what we get from these two data? We have got that if between two groups any two persons amount is equal to another two persons amount in the second group, then the amount with the third person from the first group is equal to the amount with the third person from the other group. Okay, and the same rule is applied here. Here also you can see in this triangle OBC and the triangle OAD, this angle is equal to this angle and this angle is equal to this angle. It means these two angles are equal to these two angles. So we can write that the value of this angle BCO is equal to the value of this angle ADO. Okay, do you understand it? Right. So now we can write that this angle ADO is equal to this angle, that is BCO. Okay. So instead of writing this, we will write ADO is equal to this angle BCO. Understood? Now it stands for also angle. Right? So now let us verify whether these three conditions follow ASA congruency or they do not follow ASA congruency. Right? So let us find. Since in this triangle we are talking about this angle 90 degree, means this angle, and BCO, this angle. So these are two angles, consecutive angles, and it is also given that this side and this sides are equal. So these two angles and this side is the included side or not? Yes, BC is the included side of the two angles. Right? So here it follows angle, side. Okay. Here also we are talking about this angle 90 degree and this angle ADO and this side. So if we consider these two as consecutive angle, then this is the included side. Okay, so it also follows AAS. So both the triangle follow angle, side, angle, angle, side, angle. Hence we can write that this angle, this triangle and this triangles are congruent under ASA congruency. Okay, understood? So let us write this. So we can write that the triangle OAD is congruent to the triangle OBC under which condition, which congruency? ASA congruency. Okay, so while writing ASA congruency, you have to look at whether the triangles follow ASA or AAS. Okay, next, so it is now proved that these two triangles are congruent, right? But our ultimate goal is to prove that CD bisect AB. Okay, we have to prove that CD bisect AB. Okay, how we can prove? Let's see. Since it is given that triangle OAD is congruent to the triangle OBC, it means this triangle and this triangles are congruent. Now remind the axiom number 7.2. According to axiom 7.2, if any two triangles are congruent, then their corresponding parts, that means their sides are equal, their angles are also equal. So here also these two triangles are congruent, then can we write that their sides are also equal? Yes, we can write CPCT by CPCT. So here we can write that in this triangles, this side OA is equal to, in this triangles, this side OB. Okay, how? By axiom 7.2. Okay, so we have proved that OA is equal to OB. Now it is clear, and we also want to prove it. See, this is the statement that we need to prove. Here also we have proved it. It means what? We proved OA is equal to OB. It means what? The length of OA is equal to length of OB. Or you can say O is the midpoint of AB. Or O is the midpoint of AB. Okay? And through this point O, CD moves. CD passes. So you can write, yes, CD bisect AB at O. Right? So you can write CD bisects AB at O. Okay? Now it is understood clearly. And now coming to the question number 4. So in the question number 4 it is given that L and M are two parallel lines. So there are two parallel lines. Suppose this is L and another parallel line. Suppose this is M. Okay, intersected by another pair of parallel lines P and Q. It means there are two parallel lines L and M. Now these two parallel lines are intersected by another two parallel lines. Okay, suppose these two are another parallel lines. Okay, this is P and this is Q. Understood? L and M are two parallel lines, so you can represent them like this, and similarly P and Q are two parallel lines. You can represent them by like this. Okay, so they are intersected. Suppose they intersect at four distinct points. There are four intersecting points. We can name them. Okay, suppose it is, you can take A, this is B, this is C, and this is D. Okay, we can name them. Now we have to show that the triangle ABC, which triangle? Triangle ABC. So here it is talking about this triangle, triangle A, B and C. Okay, so this triangle is congruent to the triangle CDA, right? So the triangle CDA, so this triangle. So whenever we draw this line, then this total quadrilateral has been divided into two parts or two triangles, and we have to show that this triangle is congruent to this triangle. Okay, so let us prove it. So let us first write what is given in this statement. It is given that L is parallel to M, clear, and P is parallel to Q, okay, and A, B, C, D are four intersecting points. Is it understood? Understand? Okay, so now we'll prove it. We have to prove that this triangle, which triangle? Triangle ABC, is congruent to the triangle CDA. So let us prove it. How can you prove that these two triangles are congruent? You can prove it by using either SAS congruency or ASA congruency. Okay, let us see which congruency is applied here, right? So see, if we consider this L and M are two parallel lines, okay, since L and M are parallel and this AC is a transversal line. Okay, we consider L and M as two parallel lines and AC. So this is A, this is C, is a transversal line. We consider it. Okay, and AC as transversal. Then tell me, if we consider this and this two parallel lines and AC is a transversal line, then can we say this angle and this angle are equal? Means this angle are equal? Yes, they are equal. Why? Because these two pair of angles are known as alternate interior angles. Hence, we know that the alternate interior angles are equal. So we can write that this angle is equal to this angle. Okay, so we can write that BAC is equal to which angle? DCA. Why? Because they are alternate interior. Are you getting this? Okay. Next thing. Now we will consider P and Q two parallel lines. Since P and Q are two parallel lines, okay, which two line? P and Q. Okay, let us draw it. Suppose this is P, this is Q. Two parallel lines, and this is a transversal line. This means AC is a transversal line and AC edge transversal. Then tell me, can we write this angle and this angle are equal if these two are parallel line and this is the transversal line? So this and this are two parallel lines and AC is a transversal line. Then can we say that this angle is equal to this angle? It means, can we say this angle and this angle are equal? Yes, they are equal because they are alternate interior angles. As you know, the pair of alternate interior angles are equal. That is why these two angles will be equal. Right? Since I have drawn it separately so that you can understand it easily. Okay, here P and Q are two parallel lines. AC is a transversal line. Okay, so this angle is equal to this angle. This angle is equal to this angle. Okay, so we can write this angle means which angle? Angle BCA is equal to this angle DAC because they are alternate interior. Okay, now you get this? Now we will compare these two triangles and prove whether they are congruent or they are not congruent. So let us compare them. Right? So between triangle ABC and triangle CDA, not ADC, CDA, you have to write in proper order. Okay, so here the first condition is see, in the triangle ABC this angle and in the triangle CDA this angle are equal or not? Yes, they are equal because they are alternate interior. Why? Because we have proved it that BCA is equal to DAC, this angle. So you can write it. So you can write that BCA is equal to DAC. Okay, why? They are alternate interior. Done. Next. Okay, see, if we consider this as a triangle, then AC is a side of this triangle. Which triangle? AC is a side of which triangle? ABC triangle. And if we consider this triangle, CDA, then this AC is also another side of this triangle of CDA. Yes or no? Yes. So what do we find here? We find that AC is the common side to this triangle and to this triangle. So you can write CD is equal to CD. Why? Because it is common side. Right? Next. Now, in this triangle ABC, this angle, which angle? This angle. Right? Which angle? BAC, this angle is equal to, in this triangles, this angle. Which angle? DCA. So BAC is equal to DCA. Why? Because we have already proved BAC is equal to DCA. Why? Because they are alternate interior. Right? So you can write BAC is equal to, okay, BAC is equal to DCA. Right? Sorry, I have written wrong here. It is not CD. It is not CD. Sorry. Extremely sorry. It is AC. AC is equal to AC. Okay. Now it is also proved. So from the three conditions we get here, this stands for angle, this stands for side, this stands for angle. So what we get? We get that in this triangle ABC, this angle this angle and the included side is equal to, in this triangle CDA, this angle and the included side. So by ASA congruency, we can write that these both triangles are congruent. Okay, hence we can write by ASA congruency, triangle ABC is congruent to the triangle CDA. Okay, now it is proved. So initially it is given that this line and this line are parallel. So you can write this angle is equal to this angle. Why? Because if it is a transversal line, then these two angles are known as alternating angle. Similarly, secondly, it is given this line and this line are parallel. If we consider this as a transversal line, then this angle and this angle will be equal as they are alternating. Now, in this triangle ABC, this is a side. Now, this is also a common side to the triangle CDA. So, by ASA congruency, these two triangles will be congruent. Understood?